In this video, I am going to teach some multiple choice questions from signals and its classifications. Question number 1. A signal that is defined at all instant of time. A signal that is defined at all instant of time is referred to as. See to this waveform, here a signal can be defined at every instant of time. At each and every instant of time, a signal can be defined. So, such type of signal is referred to as continuous time signal. So, the answer is option C, continuous time signal, right? Now, if a continuous time signal x of t is sampled every t seconds, a sequence x of nt results. The sequence value are referred to as, this is a continuous time signal. While sampling this continuous time signals, we get samples, right? Okay. So now, this sequence are referred to as samples. Okay, this sequence are referred to as samples. That is, this sequence from here to here, it is referred to as samples. Okay, so if a continuous time signal is sampled every t seconds, a sequence x of nt results. This is sequence. The sequence values are referred to as samples. Okay, so the correct answer is option B. Okay, option B, samples. Now, the third question, a signal has a value defined only at discrete points in time. Okay, now see to this waveform. Here the signal is defined only at a particular time instant. This time instant, this time instant, this time instant. Whether a signal is defined at this time instant? No. Okay, a signal is defined only at a particular time instant. Okay, so that's why if a signal is defined at a particular time instant, it is referred to as discrete time signal. Okay, so a signal has a value defined only at discrete points. Discrete points means at a specific point, at a particular point. Okay, it is referred to as discrete time signal, right? Okay, so the next question is another name for unit sample signal. Okay, so another name for, basically we have signal like unit step signal, ramp signal, impulse signal and so on. Okay, so another name for unit sample signal is unit impulse signal. Okay, keep it in mind. Another name for unit sample signal is unit impulse signal. Correct answer is option B. What is the relationship between impulse function and unit step function? Okay, so here 4 options are given. Here, which option gives the correct relationship? Okay, so let's say which option gives the correct relationship. See, basically we have integral minus infinity to plus infinity del of dt is equal to 1. Similarly, u of t is equal to 1 for t greater than or equal to 0. So, shall we take integral minus infinity to plus infinity del of t dt is equal to u of t. Okay, so this option, the option B is correct. Okay, and one more thing, this option B can be written as del of t is equal to du of t by dt. Okay, so this option B can also be written as del of t is equal to du of t by dt. So, what is the correct option? A, both A and B are correct. Okay, so the correct answer is option D. Okay, the thing is unit impulse function, based on the properties of unit impulse function, integral minus infinity to plus infinity del of t dt is equal to 1. Similarly, the definition for u of t is equal to 1. So, we are taking integral minus infinity to plus infinity del of t dt is equal to u of t. So, this is option B. This option B can be written in another form as del of t is equal to du of t by dt. So, both option A and B are right. Okay. So, here the correct option is option D. Now, below graphical representation implies. Okay, so this is a graphical representation given. This graphical representation implies which signal? Which signal it is? It is nothing but unit ramp signal, because for unit ramp signal, if the time input is 1, okay, the R of t is equal to 1. At time t is equal to 2, R of t is equal to 2. Similarly, at time t is equal to 3, R of t is equal to 3. Okay, so based on this, the R of t is equal to t for t greater than or equal to 0. Okay, so this graphical representation implies unit ramp signal, right? Next, give the relationship between unit step signal and unit ramp signal. Okay, so we are asked to give the relation between unit step and unit ramp. Let's see the definition for unit ramp. R of t is equal to t. For unit ramp signal, R of t is equal to t for t greater than 0. R of t is equal to t for t greater than 0. Now, differentiating R of t, what do you get? What is dr of t by dt? It is equal to 1. Similarly, what is the definition for unit step function u of t is equal to 1? So, shall we write u of t is equal to dr of t by dt? Okay, see, the question is to obtain the relation between step and ramp. Write the definition for ramp. R of t is equal to t for t greater than or equal to 0. While differentiating this, what do you get? dr of t by dt. Differentiating this, what do you get? 1. Similarly, the definition for u of t is equal to 1. Okay, so from this, shall we write u of t is equal to dr of t by dt? Okay, so this is the relation. U of t is equal to dr of t by dt is the relation between unit step and ramp signal. So the correct answer is option B. The signal x of t is equal to a into e power sigma plus j omega into t is exponentially increasing for. Okay, this is a signal. This signal is exponentially increasing for we have 4 options. Okay, from these 4 options, for which option it is exponentially increasing, we have to identify. Okay, if the signal is exponentially increasing, sigma will be greater than 0. If the signal is exponentially increasing, sigma should be greater than 0. So, which is the correct option? Option A. Actually, similarly, if the signal is exponentially decreasing, sigma will be less than 0. Okay, so here the question is exponentially increasing for. It is increasing for sigma greater than 0. The correct option is A. Next, next question is impulse function del of minus t equal to del of t. Whether it is true or false. Let us check. Del of t is equal to, the definition of del of t is equal to 1 for t equal to 0. Similarly, the definition for del of minus t is 1 for minus t equal to 0. Minus t equal to 0 can be written as t equal to 0. So, both are same. Del of t and del of minus t are same. So, del of minus t is equal to del of t. So, it is true. So, the option is A, right? Now, a signal in which its amplitude can be predicted at any time is referred to as. Okay, actually, we have a signal, and if its amplitude can be predicted, okay, predicted correctly, the exact amplitude can be predicted, it is referred to as deterministic signal. Similarly, a signal in which the exact amplitude cannot be predicted is referred to as random signal. Okay, a signal in which exact amplitude can be predicted is referred to as deterministic signal, and a signal in which exact amplitude cannot be predicted is referred to as random signal. So, the correct option is option B. Next. Question number 11. Consider a signal x of t. Here capital T be the fundamental time period. The signal is said to be periodic. When a signal is said to be periodic? A signal is said to be periodic if x of t plus capital T, where capital T is nothing but a fundamental time period, it is equal to x of t. Okay, so this is the basic definition. A signal is said to be periodic if a signal x of t is said to be periodic if x of t plus capital T is equal to x of t. So the correct answer is option B. Now, the fundamental period of a sinusoidal signal having frequency omega naught is t is equal to 2 pi by omega naught. Okay, see, the question is the formula to find the fundamental period of a sinusoidal signal is t is equal to 2 pi by omega naught. Whether it is true or false. It is true. This is the formula to find the fundamental period. So the answer is option A. Now, the signal x of t is equal to sine 20 pi t. Whether it is, we have four options, whether it is periodic or aperiodic. First, let us find whether it is periodic or aperiodic. Now, from this signal, actually, the general representation of a signal is sine omega t. Here, omega is equal to 20 pi. Now, the fundamental period t is equal to 2 pi by omega. So, 2 pi divided by 20 pi, the answer is 0.1 second. Okay, see here it is 1 by 10. It is a ratio of integer. Hence, it is said to be a periodic signal. So, periodic signal with the period 0.1. Which option is right? Periodic with the period t is equal to 0.1. So, the correct option is option A. Right? Now, next question. Given x of n equal to cos 1 by 2n, the signal x of n is, here x of n, n means it is discrete. Okay, n means it is discrete. Okay, so here cos omega n, the general representation is cos omega n. So here omega is equal to 1 by 2. Okay, so if it is discrete, the formula is n is equal to 2 pi by omega. Okay, n is equal to 2 pi by omega. We have to find n. n is equal to 2 pi by omega. Okay, so here it is not t, it is equal to n. Okay, it is equal to n. n is equal to 2 pi by omega. So simplifying, we get n is equal to 4 pi. The answer is n is equal to 4 pi seconds. Okay, so if you see to this ratio, this is not the ratio of two integer, so it is said to be an aperiodic signal. So the correct option is option B, aperiodic. Then question number 15. Any signal that exhibits symmetry in the time domain about origin is said to be. Okay, actually this waveform is an example for a symmetry signal in time domain. Okay, so what is this waveform? This waveform is said to be an even signal. Okay, a signal that exhibits symmetry in the time domain about the origin is said to be an even signal. This is an example for symmetry signal in the time domain. Okay, so the correct answer is option B, that is even signal. Next, question number 16. Consider a signal x of n. If x of minus n is equal to minus x of n, the signal is. For example, consider a signal, it is x of t. Here, substitute t is equal to minus t, sine of minus t. What is sine of minus t? Minus sine t. So, it is nothing but minus x of t. Okay, so x of minus t is equal to minus x of t. So, if x of minus t is equal to minus x of t, the signal is said to be odd function. Based on that, here x of minus n is equal to minus x of n means it is said to be an odd signal. Similarly, if x of minus n is equal to x of n means it is said to be an even signal. So, the answer is option D.